Some of Earth's greatest mountains have vanished without a trace. We are tracking down these ghost mountains, the lost peaks erased from our maps and memory. This journey will arm you with a startling new perspective on our planet's impermanent nature, revealing how even its mightiest features are not as permanent as they seem. How did entire ranges disappear from both the land and legend? What secrets lie buried with them? We will uncover the cutting-edge science resurrecting these fallen giants and the ancient stories that never let them be forgotten. What does the disappearance of something so monumental tell us about our own world? A cartographer from the age of exploration once carefully inked a mountain range onto a map, a permanent feature in a world of unknowns. Yet today, our most advanced satellites sweep over that same territory and find only empty space. This is the core of the ghost mountain mystery. These are not mere hills that slowly wore down over millennia. They are geological enigmas, significant formations that have been utterly erased from both our landscapes and our records. The processes capable of such a feat are as powerful as they are varied. Imagine a mountain range caught in the colossal crunch of tectonic subduction, dragged slowly and relentlessly beneath the Earth's crust until not a trace remains on the surface. Or consider the sheer power of catastrophic erosion, where Ice Age glaciers acted like planetary sandpaper, scouring entire peaks down to their roots. What makes these lost peaks so compelling, however, is the paper trail they left behind. Historical accounts from multiple, often disconnected, cultures describe towering landmarks that our modern science simply cannot locate. Sailors' logs, explorers' diaries, and indigenous oral traditions all speak of mountains that should be there, creating a profound disconnect between our documented history and our present reality. This forces us to ask, how do we even begin to search for something that is no longer there? The quest to resurrect these ghost mountains sits at a fascinating intersection, where the hard data of geology meets the clues of archaeology and the enduring whispers of mythology. These vanished peaks leave behind a ghostly signature in the very rocks they once towered over. To find them, scientists must become geological detectives, reconstructing a cosmic crime scene where the victim is an entire mountain. The evidence is subtle, written not in words but in the chemistry of ancient minerals and the magnetic memory locked inside stones. One of the most powerful techniques is sediment analysis. As a mountain erodes, it sheds countless grains of rock, each one a tiny piece of its history. By studying the layers of sediment in surrounding plains or the basins of ancient rivers, researchers can trace these mineral crumbs back to their source, like following a trail of cosmic breadcrumbs. They can determine not just what the mountain was made of, but even estimate its former grandeur by the volume and spread of its own dismantled pieces. Another crucial tool is isotopic dating, which acts as a geological clock. Certain elements within rocks decay at a steady, predictable rate. By measuring the ratio of the original element to its decay product, scientists can pinpoint the moment those rocks cooled and solidified, revealing the precise age of the mountain's formation and its eventual dismantling. Then there is paleomagnetism, a truly remarkable method. When rocks form, particularly volcanic ones, tiny magnetic minerals within them align themselves with the Earth's magnetic field at that time, freezing that orientation in place like a fossilized compass. By studying this preserved magnetic signature, geologists can determine if a rock layer has been tilted, folded, or even rotated from its original position, revealing the colossal forces that twisted and ultimately destroyed a peak. The search even extends to the ocean floor. Core samples drilled from deep-sea sediments near continental margins often contain mineral evidence of mountains that have been completely dragged beneath tectonic plates and swallowed by the Earth's mantle. These deep-sea mud samples hold the final, ground-up remains of entire ranges. This forensic approach reveals a profound truth. Mountains do not simply vanish into nothingness. They transform, their substance is recycled, their minerals becoming part of new landscapes, their story told in chemical fingerprints and magnetic whispers. Understanding this continuous transformation forces us to appreciate our world not as a static photograph, but as a dynamic, ever-changing film. The evidence does not stop at the microscopic level. From the chemistry of ancient minerals, we now look to the sky, where modern satellites act as high-tech seers for lost worlds. These orbital observers use a form of gravity-based vision to detect the ghosts of mountains long gone. The principle is both simple and profound. A massive mountain range, even after it has been completely flattened by erosion, leaves a permanent dent in the Earth's gravitational field. Its deep, dense root, like the submerged bulk of an iceberg, still exerts a subtle pull on the space around it. Sensitive instruments aboard satellites can measure these tiny gravitational tugs, mapping anomalies that betray the presence of a colossal structure hidden beneath miles of sediment or even vast ice sheets. It is like feeling the weight of a sunken ship by the way the water flows over it. This celestial detective work is augmented by other tools. Satellite-based LIDAR and radar altimetry fire pulses of light or radio waves at the Earth's surface, building precise topographical maps that can strip away modern forests and cities to reveal the bare bones of the landscape. In some cases, these technologies have sketched the spectral outlines of entire ancient ranges, sleeping beneath the flat, featureless plains of continents or the immense weight of polar ice. The data from orbit is then combined with ground-penetrating radar, which acts like an ultrasound for the planet, sending signals deep into the crust to echo off buried rock layers. By weaving these threads of information together, scientists can perform a kind of digital archaeology, constructing stunning three-dimensional models of lost worlds. We can now see with measurable certainty the silhouette of a mountain range that vanished tens of millions of years ago, its form resurrected not from rock but from data. This high-tech resurrection is quietly revolutionizing our understanding of the planet, proving that even a ghost leaves a shadow in the forces that shape our world. These climatic ghosts linger long after the mountains themselves have crumbled. The very air and life of a region hold memories of the barriers that once shaped them, and paleoclimatologists are the specialists who learn to read this forgotten language. They turn to natural archives like ice cores, which trap ancient air bubbles and dust in pristine layers, creating a timeline of the atmosphere's past. A dramatic shift in these records, such as a sudden change in precipitation patterns or wind-borne minerals, can signal the removal of a massive rain shadow, a clear sign that a mountain wall has fallen. Similarly, the rings of ancient trees tell a story of rainfall and temperature. A centuries-long drought recorded in their growth could mark the geological moment a protective peak vanished, allowing dry winds to sweep across lands they once sheltered. The story is also written in stone and sediment through fossil evidence. Plants and animals are not randomly distributed. They are meticulously adapted to specific environments. Finding the fossilized remains of a high-altitude alpine plant, one that could only survive in the thin, cold air of a mountainside, in a layer of rock that now lies flat and low, is like discovering a seashell on a desert dune. It is a profound anomaly that points to a world turned upside down, or more accurately, a world flattened. That fossil is a direct testament to a lost high-altitude habitat, a ghost ecosystem that simply could not exist without its mountain. Perhaps the most delicate clue comes from pollen. Each type of plant produces pollen grains with a unique shape, and these microscopic particles are incredibly durable, preserving for millions of years. By mapping the distribution of different pollen fossils in sediment cores, scientists can reconstruct ancient wind patterns, a sudden, sharp boundary in the pollen record, where the spores of one type of plant abruptly end and another begins, suggests an invisible wall that once stood in the atmosphere, the wind-blocking presence of a mountain range that guided and filtered the winds. By piecing together these disparate clues, the testimony of ancient ice, the location of a fossil fern, the map of primordial pollen researchers can perform a stunning act of environmental resurrection. They can not only estimate where a ghost mountain stood, but also paint a vivid picture of the climate it created and the life it sustained. This reveals a deep, interconnected truth. Earth's topography is not just a stage for life and climate, but the primary sculptor of both. These cultural echoes are not vague rumors, but often startlingly precise descriptions. In Australia, the ancient stories of the Aboriginal peoples, known as Dreamtime narratives, speak of creator beings who shaped the land, forming specific mountains and rivers. Geological surveys now confirm that some of these described peaks have been completely worn down to gentle hills over hundreds of thousands of years. The stories outlasted the stone, preserving a map of a world that erosion slowly unmade. Far to the north, the Norse sagas written in medieval Iceland tell of formidable, ice-capped mountains encountered by early settlers in Greenland. Yet when modern adventurers retrace those ancient routes, they find only empty fjords and low-lying plateaus where the sagas promised towering peaks. This is not a case of myth-making, but of landscape unmaking. The geographical details embedded in these tales are too specific to be pure invention. They read like eyewitness accounts of a terrain that has since vanished, suggesting that the first people to arrive in these lands saw a different, more dramatic skyline than the one we see today. What does it mean for a mountain to live on in a song long after its rock has turned to dust? This persistence reveals a profound connection between geography and human identity. A peak is more than just a pile of stone. It is a landmark for navigation, a source of water, a sacred boundary, and a character in a community's story. When that physical anchor disappears from the horizon, its memory is woven into the fabric of culture, becoming a foundational pillar of mythology. These legends, passed down through countless generations, become a unique form of historical record. They are not written on parchment or stone, but in the living memory of a people, offering us a priceless key to reconstructing lost worlds. They allow us to see through the eyes of our ancestors, to glimpse the ghost mountains that once defined their reality. A mountain is far more than its physical mass of rock and ice. In the deep past, these colossal structures were seen as the very pillars holding up the sky, the sacred stairways connecting the human world to the realms of the gods. Their disappearance was not just a geological event, it was a cosmological catastrophe, a tear in the fabric of reality itself. The ancient Hindus envisioned Mount Meru as the axis of the entire universe, a golden mountain around which the stars, sun, and planets all revolved. It was the central pole of existence, yet for all its profound importance, its physical location on any earthly map remains one of history's great enigmas. Was it ever a real place that eroded into myth, or was it always a spiritual concept born from the human need for cosmic order? This same duality existed for the Greeks with Mount Olympus. It was a tangible peak you could point to, yet it was simultaneously a metaphysical dwelling place, invisible to mortal eyes, where the gods shaped human destinies. When such a culturally central mountain becomes lost, when it cannot be reliably found or is seen to have faded from the world, it forces a profound shift. The connection between the land and the divine is severed. The map of the known world develops a blurry, uncertain center. These peaks were organizing principles for entire civilizations, the fixed points around which calendars, rituals, and kingdoms were arranged. Their ambiguous presence in our records challenges us to understand how human consciousness memorializes the world. We do not simply record what we see, we weave observation with imagination, creating stories so powerful they can outlast the very landforms that inspired them. The Ghost Mountain, therefore, lives on in two places, in the subtle gravitational anomalies detected by satellites, and in the enduring myths that continue to give it a shadowy form in our collective mind. The legend of Atlantis is a ghost story written in water. Plato's ancient account describes a magnificent island kingdom, encircled by great mountain ranges that plunged into the sea in a single day and night of catastrophic earthquakes and floods. For centuries, this was dismissed as pure philosophical fiction, a moral tale about hubris. But what if the mountains themselves hold the key to a geological truth? The search for Atlantis is in many ways a search for its lost peaks, and this quest has led scientists to some of the most dramatic ghost mountains on Earth. One compelling candidate lies deep in the Atlantic Ocean. The Azores Plateau is a sprawling underwater platform where volcanic peaks once scraped the sky. Geological cores extracted from the seabed reveal a stunning history. This entire region underwent a process of massive tectonic subsidence, a gradual sinking of the Earth's crust that may have accelerated into a sudden collapse. Around 12,000 years ago, a date that eerily echoes Plato's timeline, entire islands and their mountainous spines may have been dragged beneath the waves, swallowed whole by the ocean. The description of a circular city ringed by high mountains could match the calderas of sunken volcanoes, their rims forming that iconic shape. Another, more terrestrial possibility emerges from the sands of Mauritania. The Richat structure, often called the Eye of the Sahara, is a vast circular formation visible from space. While not a sunken city, it presents a different kind of disappearance. Geologists now understand it as the deeply eroded remnant of a gigantic geological dome. What we see today is the flat, circular pattern of its roots. Millions of years ago, this was a prominent uplift, a mighty peak that would have dominated the ancient landscape. Relentless wind and water erosion planed it down to its base, leaving only a ghost of its former shape imprinted on the desert floor. Could early human cultures have witnessed the final stages of its erosion, passing down stories of a great circular mountain that vanished into the sand? The persistent, global search for the mountains of Atlantis demonstrates a powerful feedback loop between myth and science. A legend provides a tantalizing description, and that description drives genuine geological inquiry. Each potential location, whether submerged beneath the Atlantic or eroded in the Sahara, forces us to ask how a real mountain range could so completely vanish from human knowledge that its memory survives only as a fantastical tale. This transforms the search from a hunt for a fictional kingdom into a serious investigation of planetary change, proving that some of our oldest stories are maps to the world's deepest losses. The blank white spaces on early Antarctic maps held more than just unknown territory. They held mountains that were not there. Sir Hubert Wilkins, a pioneering aviator, returned from his 1929 flight across the Antarctic Peninsula with a stunning claim. He reported seeing and meticulously mapping a substantial range he named the Phillips Mountains, Subsequent expeditions sailed directly to his coordinates, scanning the horizon with powerful lenses, but they found nothing. No jagged peaks, no dark rock breaking through the ice, only the endless, flat expanse of the white desert. The mountains had vanished from the earth as completely as if they had been a dream. This was not an isolated case. For decades, the Edsel Mountains were charted on official maps of the continent, a phantom range born from a similar misidentification. How could experienced explorers, men trained in observation, be so utterly deceived? The answer lies in the Antarctic itself, a land of extreme sensory deprivation. In that world of blinding white and featureless blue, the human mind desperately seeks pattern and structure. A distant bank of low-lying clouds can harden into a granite cliff in the imagination. A peculiar formation of wind-sculpted ice, seen from a great distance, can perfectly mimic the silhouette of a mountain range. These were not lies, but honest phantoms, mirages born from the interplay of light, ice, and the profound loneliness of the landscape. Once inked onto a map, such errors gained a life of their own, becoming entrenched in geographical knowledge for a generation. Yet modern technology has added a fascinating twist to this mystery. Ice-penetrating radar now reveals that the Antarctic continent hides entire mountain ranges beneath miles of solid ice, ranges we have never seen with human eyes. Is it possible that Wilkins and others did not see a mere mirage, but a subconscious glimpse of the truth? Could their minds have projected the faint, unseen topography beneath the ice onto the blank canvas of the sky? The phantom peaks of the old maps may yet be redeemed, not as errors of perception, but as premonitions of the hidden world we are only now beginning to uncover. Beneath the churning grey waves of the North Sea, an entire world lies silent. This was Doggerland, a sprawling landscape of hills, valleys, and rivers that connected Britain to Europe, a vibrant home for prehistoric hunters and gatherers. For thousands of years, its rolling highlands defined the horizon, but then the climate shifted at the end of the last ice age. Glacial meltwater began to pour into the oceans, and the sea levels rose relentlessly. The slow, inexorable advance of the water did not just drown a coastline, it systematically erased a topography, swallowing hills and perhaps even small mountain ranges whole. The high ground, the very landmarks that once guided travel and settlement, became submerged features, invisible ghosts beneath the swell. For the people who lived there, this was not a slow geological process. It was a generational trauma, a creeping loss of their entire world witnessed within a few human lifetimes. Their mountains did not crumble, they simply vanished beneath the waves, taking their place names and their stories with them. The proof of this vanished world surfaces in the most mundane of ways. For decades, fishermen trawling the Dogger Bank, once one of Doggerland's highest points, have hauled up startling artifacts in their nets. Amidst the cod and plaice, they find the bones of mammoths, the antlers of giant elk, and finely crafted stone tools left behind by those ancient inhabitants. Each discovery is a message from the deep, a tangible piece of evidence that this was not empty ocean, but a lived-in, topographically rich land. The slow disappearance of Doggerland's elevated features provides a perfect and haunting model for how coastal mountains can be erased from human awareness. It was a dual assault of rising waters and the land itself subtly sinking under the weight of the new sea, a process known as isostatic adjustment. This case demonstrates with chilling clarity how climate change and sea level rise do not merely redraw coastlines, they annihilate entire landscapes, wiping mountains from the map and eventually from memory itself. What other highlands, what other pillars of ancient worlds now sleep beneath the sea, waiting for their story to be told? The most dramatic vanishing act a mountain can perform is not erosion but descent. Plate tectonics reveals a planet in constant, slow-motion collision, and at these convergent boundaries, an entire range can be dragged back into the abyss. This is the process of subduction, a geological conveyor belt where one tectonic plate slides inexorably beneath another. The colossal mountains built by this very collision are, in time, carried down on the descending plate, sinking into the intense heat and pressure of the Earth's mantle. They are not worn down to sand but effectively consumed, recycled into the planet's fiery interior. The evidence for this is written in the scars left on the overriding continent. Look at the western coast of North America. Today we see the mighty Sierra Nevada and the Cascades, but these are relative newcomers. They stand where even greater, more ancient mountains once soared, mountains built by the now vanished Farallon Plate. As the Farallon Plate slid beneath the North American continent, it did more than just push up peaks. It fueled massive volcanic eruptions and caused the continent itself to buckle and warp, leaving a permanent record of its passage in the deformed rock layers we can still study today. The final fate of those lost ranges was to follow the plate that bore them, sinking into the mantle until not a single summit remained above the waves. This relentless tectonic recycling offers a humbling perspective. It means that every mountain we see today, no matter how permanent it appears, is ultimately on borrowed time. The very forces of creation that thrust rock towards the sky are the same forces that will one day pull it back into the darkness, a reminder that our world is a stage for cycles far grander than human history. This slow, patient dismantling of stone is a planetary constant. While subduction swallows mountains in a geological instant, erosion performs a more thorough vanishing act over immense spans of time. It is the work of water, wind, and ice, a relentless, granular demolition that grinds down peaks grain by grain. The ultimate evidence of this process is written across the gentle, rolling spine of the Appalachian Mountains. Today, they are a landscape of forested ridges, but once they stood as tall and jagged as the modern Himalayas, a colossal wall formed by ancient continental collisions. Over hundreds of millions of years, every drop of rain, every freezing crack of ice, and every gust of wind has carried away microscopic pieces of that former glory. What we see now is not the mountain, but its deeply eroded root, the stripped-down core of a fallen giant. In landscapes of softer rock, like the chalk hills found in parts of Europe, the process can be even more complete. These fragile mountains can be scrubbed from the map so entirely that they leave behind only a layer of distinctive sediment and a puzzling flatness where peaks should logically be. This is why the absence of a mountain on a modern map is not proof it never existed. Its entire substance may have been transported away by rivers, spread across distant plains, and deposited on silent seafloors. The timeline for this erasure is not fixed. A hard granite peak in a dry climate can persist for 1 billion years, while a soft shale mountain in a torrential monsoon region might be flattened in a mere 50 million. This variation means our planet holds the ghosts of mountains at every stage of disappearance, from the slightly rounded to the almost entirely forgotten. The very ground beneath our feet, so seemingly solid, is in a state of continuous slow-motion flight. The ice itself can be a perfect shroud, hiding mountains from human history for thousands of years. In the planet's great cold cycles, colossal ice sheets did not just cover valleys, they buried entire mountain ranges, transforming them into anonymous, subglacial features. For every civilization that has ever existed, these peaks were simply not part of the world, their existence completely unknown. Now, as the climate warms, these glaciers are pulling back and the mountains are returning. In the high Arctic and the great ranges of the world, previously undocumented peaks are literally emerging from the ice for the first time in recorded human history. It is a resurrection in reverse, a slow unveiling of a world we never knew was there. This process creates a strange paradox. As new mountains are being discovered, others are vanishing in a different way. Some of the peaks meticulously charted by early polar explorers may not have been mountains of rock at all, but towering nunataks, which are isolated rock summits protruding from a sea of ice, or even immense structures of compressed snow and ice that mimic the shape of a mountain. When that particular ice configuration melted, the mountain simply ceased to exist, leaving no rocky skeleton behind. It was a phantom made of frozen water, here for a geological moment and then gone. This interaction between a shifting climate and a static topography creates a landscape in flux. We are witnessing mountains appear and disappear on a human timescale, not a geological one. This fundamentally challenges our deepest assumptions about the land beneath our feet. We perceive mountains as the ultimate symbols of permanence, yet they can be hidden, revealed, or even unmade by the temperature of the air. The very map of our world is not fixed, but is a transient image projected onto a dynamically changing planet. The silent stones of an ancient city hold a map to a vanished world. We can read the story of ghost mountains not only in the chemistry of rocks but in the very footprints of our ancestors. Human settlements are never random. They are a direct response to the landscape, and when that landscape disappears, the pattern they left behind becomes a fossilized echo of a lost terrain. In regions that are now flat and open, archaeologists find the ruins of cities clustered in seemingly illogical defensive positions, perched on high ground with no obvious threat in sight. Their layout only makes sense if they were once protected by a mountain wall that has since crumbled to dust. The careful placement of these communities reveals a topography we can no longer see, a strategic relationship with a giant that is no longer there. Consider the intricate irrigation canals of ancient Mesopotamia. These were not just ditches for water, they were precisely engineered systems that drew from rivers and followed specific, gentle gradients across the land. The orientation of some of these ancient waterways suggests they were designed to flow from the foothills of substantial highlands, highlands that have since been completely eroded into vast, featureless plains. The water's path remembers the slope of the mountain long after the mountain itself has forgotten its own shape. Even the winding paths of old trade routes tell a story of obstruction and passage. Why would a caravan route make a weeks-long detour around a broad, flat valley that seems perfectly easy to cross? The answer often lies in a ghost. That empty valley may have once been blocked by a formidable ridge, a natural barrier that forced trade into a specific corridor for centuries. Long after the ridge was worn down to nothing, the habit of the route and the cities that grew along it remained, preserving the memory of an obstacle that vanished millennia ago. By reverse engineering these human decisions, archaeologists perform a kind of geographical resurrection. They look at the scatter of pottery shards, the foundations of forgotten forts, and the ghostly imprints of old roads, and they ask what kind of land would make this pattern logical. The answer often points upward to a peak that once commanded the horizon, its presence so influential it continued to guide human destiny long after its physical form had returned to the earth. The silent testimony of a fossilized leaf can reveal the contours of a world long gone. Paleobotanists have learned to read these botanical archives, understanding that the plants of the past were meticulously adapted to their environment, especially to elevation. A palm tree does not grow on a windswept alpine ridge, and a delicate mountain wildflower cannot survive on a hot, lowland plain. This fundamental relationship between plant life and altitude makes fossilized flora one of the most precise tools for resurrecting ghost mountains. When researchers discover the fossils of high-altitude species in a layer of rock that now forms a flat, open landscape, it is as definitive as finding a marine fossil on a mountaintop. It signals a geological upheaval, a dramatic change that flattened a once towering terrain. In Wyoming's Green River Formation, the evidence is written in stone. The fossilized remains of delicate alpine flowers, the kind that today only cling to life in the thin, cold air of high peaks, lie embedded in shale that is now part of a relatively flat basin. These flowers are quiet but undeniable witnesses. They testify to the existence of a mighty mountain range that once cast its shadow over this land, a range that erosion patiently dismantled over millions of years, leaving its former high-altitude residents buried in the sediments of its own destruction. Another powerful clue comes from the fossilized tree line. In any mountainous region, there is a specific elevation above which trees can no longer grow, a boundary dictated by cold and wind. By mapping the distribution of fossilized tree stumps and pollen in ancient soil layers, scientists can pinpoint the exact altitude of this ancient limit. A fossil tree line discovered in an area that is now at sea level paints a startling picture. It reveals the ghostly outline of a mountain slope, allowing researchers to calculate not just that a mountain was there, but how high it truly stood. This process goes even deeper into the ecological requirements of extinct plant species. By studying the modern descendants of these ancient plants, or by analyzing the shape of their leaves and the structure of their cells, paleobotanists can determine the precise climatic conditions they needed to thrive, including temperature and atmospheric pressure, which are directly tied to elevation. This data lets them perform a stunning act of botanical resurrection. They can input these parameters and reconstruct the elevation profile of a vanished landscape with scientific precision, drawing the silhouette of a lost peak based solely on the preferences of the plants that once grew on its shoulders. The mountains themselves are gone, but their ecological shadow remains, forever captured in the fragile, stone memories of the flowers that adorned them. The silent testimony of fossils is joined by the restless motion of the sea in the search for lost peaks. Some of Earth's most dramatic ghost mountains exist entirely beneath the waves, submerged cathedrals of stone that vanished from human sight not by crumbling but by drowning. The process is twofold. Rising sea levels at the end of ice ages slowly flooded coastal ranges, turning their summits into islands and then into submerged seamounts. In other cases, the very ocean floor itself can sink in a process called tectonic subsidence, dragging entire volcanic island chains down into the abyss. The evidence for these drowned worlds is not found on land, but in the deep, pulled from the ocean floor by sophisticated drills. Marine sediment cores act as a layered diary of the deep. A core sample might show a sudden shift from coarse, land-based sand and pollen to the fine, mineral dust of the open ocean, marking the precise moment the sea finally closed over a mountain's peak. The very shape of the seafloor betrays these lost ranges. Vast, submerged plateaus are the drowned skeletons of ancient continents. East of Australia lies Zealandia, a continent almost entirely underwater. Its northern tip forms the islands of New Zealand, but the rest is a sunken world, a sprawling underwater plain that was once dominated by mountain ranges rivaling the Alps. These peaks are now silent, submerged ridges, their forests replaced by coral and their slopes navigated by deep-sea currents instead of terrestrial winds. Even more dynamic are the mountains of the Mid-Atlantic Ridge, a colossal underwater mountain chain running the length of the ocean. Here, volcanic forces constantly push new peaks upward from the seabed. Some breach the surface as jagged, newborn islands, only to be relentlessly attacked by waves and wind. Over thousands of years, these temporary summits are planed down and sink back beneath the waves, becoming seamounts. They live a brief life in the sun before returning to the eternal darkness, a cycle of birth and death played out far from human eyes. The legacy of these submarine ghosts extends beyond geology. They shape the living ocean. A submerged mountain disrupts deep ocean currents, forcing nutrient-rich water to rise toward the surface in massive upwellings. These areas become oases of marine life, attracting great schools of fish, whales, and seabirds. The mountain itself is invisible, but its biological footprint is a vibrant, swirling memorial on the surface of the sea. This reveals a profound truth about planetary change. A mountain range can be completely erased from our maps and memory, yet its influence persists, silently directing the flow of water and the migration of life in the deep, a hidden hand continuing to shape the world long after its work is done. A map is a promise of a world you can trust, but history is filled with cartographic ghosts that broke that promise. For nearly a century, a formidable range known as the Mountains of Kong stretched across the entire width of West Africa on the most respected maps of the era. It was depicted as an unbroken wall, a barrier to exploration, its peaks a permanent feature of the continent. Yet this mountain range was a complete fiction, a phantom born from a single explorer's misinterpretation, and then endlessly copied by mapmakers who never thought to question its existence. The chain of error began in 1798, when the British cartographer James Rennell added the range to his map based on the accounts of the explorer Mungo Park. Park had likely seen a distant, hazy escarpment or perhaps even a towering bank of clouds on the horizon, and his report of high ground was transformed into an impassable barrier that stubbornly remained on charts for decades. Expeditions were planned to go around it, colonial boundaries were theoretically drawn against it, and geographies were written to include it. The mountains were a shared geographical delusion, so entrenched that when later explorers traveled to the area and found only rolling savanna, their truthful reports were dismissed as error. It took until the late 1800s for the cartographic community to finally accept the truth and erase the mountains from the map, leaving a blank space where a giant had supposedly stood. A similar phantom haunted the American West. The Brendan Mountains were charted for years in California, a substantial range that simply was not there. This error likely sprang from a different source, the deliberate deception of a hoaxer or the confused account of a gold prospector, but the effect was the same. Once a feature was printed with the authority of an atlas, it gained a life of its own, its fictional peaks standing firm against the tide of contradictory evidence. These persistent mistakes reveal more than just the limits of old exploration. They expose the psychology of mapmaking. A blank space on a map is an uncomfortable void, an admission of ignorance. Cartographers, under pressure to fill these voids, would sometimes borrow from rumor, from myth, or from the sketchy journal of a single traveler. The process of correcting these errors is a perfect mirror of the scientific method. A hypothesis, the existence of a mountain, is proposed based on initial observation. It is then tested by further exploration and evidence. When the evidence consistently fails to support it, the hypothesis is finally falsified and discarded. Our modern, satellite-verified maps seem to leave no room for such phantoms, yet the legacy of these cartographic ghosts is a lesson in humility. It reminds us that our understanding of the world is always a work in progress, a canvas where we paint our best available knowledge, always aware that a more complete truth may still lie hidden, waiting to be found. Across the world, the oldest libraries are not built of stone but of memory. The oral traditions of indigenous cultures contain deep time records of the land itself, chronicling geographical events that occurred millennia before modern science had the tools to measure them. These stories, passed down with meticulous care through countless generations, often describe a world we would no longer recognize, a world where mountains that have since vanished still dominated the horizon. For the Klamath people of the Pacific Northwest, the story of the great battle between the sky god Skell and the god of the underworld, Lau, is not merely a myth. It is a precise geological record. Their oral history describes a colossal mountain, the home of Lau, that erupted in a fantastic firestorm before collapsing into itself, creating the deep blue bowl we now call Crater Lake. This narrative aligns perfectly with the scientific understanding of Mount Mazoma's catastrophic eruption and collapse around 7,700 years ago. The Klamath people witnessed this earth-shattering event and preserved its truth in a story, a testament that has endured for over 7,000 years. On the other side of the globe, the Aboriginal peoples of Australia navigate the continent through songlines, intricate pathways of knowledge woven into the landscape through song and story. Many of these songlines describe the specific forms of mountains and highlands that have been softened by erosion into the gentle hills we see today. The stories remember the shape of the land long after the wind and rain have remade it, holding a map of a more rugged, ancient world. These are not vague legends but detailed environmental accounts. They encode knowledge of sea level changes, the locations of springs that have long since dried up, and the migratory paths of animals from climates past. When this indigenous knowledge is placed alongside core samples and carbon dating, a powerful convergence emerges. The stories provide a human-scale timeline and a vivid, experiential account that hard data alone cannot offer. They answer not just when a mountain fell, but what it meant to the people who saw it happen. This partnership between ancient memory and modern method offers a more complete form of resurrection, allowing us to understand these ghost mountains not just as geological features, but as living pillars of culture that were witnessed, revered, and mourned. These digital reconstructions begin with a landscape stripped bare of its modern features. Scientists feed vast datasets into complex algorithms, including the precise chemistry of ancient rocks, the known speed of erosion for different stone types, and the relentless vectors of tectonic plate movement. The computer then runs a simulation across millions of years, not as a single event, but as a continuous, flowing animation. We can watch a flat plane suddenly buckle and wrinkle, its crust folding under immense pressure as peaks claw their way toward the sky. We witness the newborn range at its maximum height, a jagged, youthful topography of sharp ridges and deep valleys. Then the slow demolition begins. The simulation visually calculates the work of every raindrop and glacier, showing the peaks softening, the valleys filling with sediment, and the entire structure gradually sinking back toward the earth. The model can even run different scenarios. What if the climate had been wetter? The erosion accelerates dramatically. What if the tectonic collision had been slower? The mountains would have risen less, vanishing far sooner. This is more than a simple animation. It is a rigorous testing ground for geological theories. Does the final, flattened result of the simulation match the real-world geology we see today? If it does, we have a compelling, visual story for a ghost mountain's entire existence. These models breathe life into data, transforming abstract numbers into a visceral, visual journey through time. We are no longer just studying rocks, we are witnessing the life and death of a landscape. These fallen giants force us to confront a profound geological truth, that permanence itself is an illusion. We build our civilizations in the shadow of mountains, trusting in their eternal presence. Yet the science of ghost mountains reveals that every peak is merely a temporary arrangement of stone. This is a reality recognized by ancient philosophies long before modern geology provided the evidence. The Buddhist principle of impermanence, or anicca, teaches that all conditioned things are in a constant state of flux and decay. The Greek philosopher Heraclitus observed that you cannot step into the same river twice, for fresh waters are ever flowing in. He was speaking of the fundamental nature of a universe where change is the only constant. Our planet is that river on a grand scale. The continents we stand on are not fixed landmasses but slow-moving rafts on a molten sea. The mountains that define our horizons are transient wrinkles on a shifting skin, here for a geological moment before they are smoothed away by the relentless forces of erosion and tectonics. This understanding collapses our sense of time. Human history is a brief flicker in the long night of Earth's existence. The pyramids are young, the last ice age was yesterday, and the Appalachian Mountains, now gentle rolling hills, were ancient ruins when the dinosaurs first appeared. Our entire recorded history has unfolded on a stage that is itself in motion, its backdrop continuously being dismantled and rebuilt. How does this perspective alter our relationship with the land? Knowing that the familiar landscapes we call home are fleeting gifts, not permanent possessions, might instill a deeper sense of stewardship. If we see a mountain not as an eternal monument but as a temporary work of art, shaped over 100 million years and destined to eventually fade, does it not become more precious, more worthy of our protection? The ghost mountains teach us a final, humbling lesson. We are not the masters of a static world, but fleeting guests on a dynamic, living planet that is always quietly remaking itself. This powerful intersection of storytelling and science opens a new door for education, transforming the classroom into a detective's laboratory. The enigma of ghost mountains provides a captivating gateway into fundamental Earth science, turning abstract concepts like plate tectonics and erosion into a tangible mystery waiting to be solved. Instead of memorizing facts, students become investigators, piecing together clues to answer a single, compelling question: where did the mountain go? This narrative framework makes the science unforgettable because it is tied to a human-scale story of loss and discovery. A lesson on sedimentation is no longer about layers of rock. It is about analyzing a simulated sediment core for the mineral evidence of a vanished peak. The complex process of subduction is no longer a diagram in a textbook. It is a hands-on activity where modeling clay is used to simulate one tectonic plate slowly consuming another, hiding a mountain range from view. By comparing a historical map that shows the Phillips Mountains with a modern satellite image of the same empty Antarctic expanse, students directly confront the nature of scientific error and revision. They learn that science is not a static collection of settled facts, but a dynamic, self-correcting process of inquiry. This pedagogy of perplexity leverages our innate curiosity about lost worlds and hidden histories. The search for a ghost mountain naturally leads students through the entire geological toolkit, from radiometric dating that reveals a mountain's age to paleomagnetism that shows how its foundations were twisted. They are not just learning about science, they are doing science, following the same logical pathways and evidentiary trails as professional geologists. This approach demonstrates that the most profound scientific education often begins not with an answer, but with a truly great mystery. The next generation of exploration will not look to the horizon, but directly through it. Emerging technologies are giving us the ability to see through solid rock and deep time, promising to reveal ghost mountains we do not even know are missing. At the forefront are quantum gravity sensors, devices of astonishing sensitivity. They do not measure light or sound, but the infinitesimally small variations in the Earth's gravitational pull. A mountain root, even one buried under miles of sediment, is so massive and dense that it creates a minute gravitational shadow. These sensors can detect that shadow, mapping the ghostly outline of a mountain's foundation with a clarity we have never before possessed. It is like developing a new sense, one that feels the weight of history. Even more profound is the potential of neutrino tomography. Subatomic particles called neutrinos are cosmic ghosts, streaming through the universe and passing through our planet as if it were not even there. A hypothetical future detector could analyze how these particles are subtly altered as they pass through the Earth, building a three-dimensional image of our planet's interior structure. This could allow us to see the subducted remains of entire mountain ranges hundreds of kilometers deep within the mantle, tracing their final journey into the abyss. Alongside these physical tools, artificial intelligence provides a new kind of intellectual partner. Machine learning algorithms are now being trained on vast geological datasets, learning to recognize the complex, multi-layered signatures of a vanished peak. They can find patterns in the chaos of erosion, connections in scattered mineral data, and subtle clues in ancient magnetic fields that would take a human researcher a lifetime to uncover, if they could see them at all. As these technologies mature, they may finally resolve the locations of legendary peaks like Mount Meru, or reveal entire cordilleras that rose and fell before the first mammals walked the Earth. The future of this search is not about finding mountains we have lost, but about discovering the ones we never knew existed, developing new ways to see through time and rock simultaneously. The shadow of vanished peak casts can be longer and deeper than the mountain itself. When a landmark that defines a horizon disappears, it leaves a void not just in the landscape, but in the human heart, and that emptiness often fills with story, song, and a powerful sense of identity. Across the rugged coast of Wales, the legend of Cantragwaelod endures, a haunting tale of a magnificent kingdom protected by sea gates, complete with its own dramatic highlands, now lying silent beneath the waves of Cardigan Bay. The story is not merely a folk tale, it is a cultural pillar, immortalized in countless poems and stirring musical compositions that speak to a profound, collective sense of loss for a drowned world. The ghost mountains of this sunken realm are remembered not with geological data, but with melody and verse, their memory a testament to Welsh resilience in the face of change. Far to the east, a different kind of spectral topography fuels cultural identity. The lost continent of Cumri Kandam, described in ancient Tamil literature, is said to have been framed by magnificent mountain ranges that sank into the Indian Ocean. Though its physical existence remains unproven, the idea of this sophisticated homeland, with its lost peaks and valleys, has become a powerful symbol for Dravidian culture. It represents a golden age, a source of linguistic and cultural purity, and its story continues to influence art, literature, and even political movements that draw strength from this shared ancestral memory of a vanished world. Why does the absence of a place often hold more power than its presence could ever possess? A real mountain can be mapped and measured, but a ghost mountain exists in the realm of pure meaning. It becomes a blank canvas upon which a people can project their deepest values, their history of displacement, their hopes for restoration, or their nostalgia for a homeland that may never have existed in the way they remember. This cultural memorialization is an act of defiance against the finality of geological change. It ensures that these lost landscapes continue to shape collective consciousness, directing the flow of art and the course of political thought for generations. The mountain itself may be gone, reduced to sediment or resting on the abyssal plain, but its cultural echo, its role as a touchstone for identity, resonates through time, proving that the most enduring monuments are sometimes built not from stone but from story. These silent geological events hold urgent lessons for our own environmental future. The rate at which an ancient mountain crumbles directly predicts the fate of our soil. When a mighty range like the Appalachians was ground down over millions of years, its substance was carried away by rivers and spread across continents, creating the fertile plains that would later feed civilizations. But this process reveals a delicate balance. The same erosive forces that built that soil are now accelerated by human activity, stripping away this precious resource at a pace that far outpaces its natural formation. The ghost mountains teach us that soil is not a permanent possession, but a fleeting gift from the erosion of giants, one we are currently squandering. Beneath the very ground we walk on, a deeper cycle is at work. The subduction of entire mountain ranges, dragging colossal volumes of rock into the Earth's mantle, is a primary regulator of our planet's climate. This process is part of the long-term carbon cycle, a planetary thermostat operating over millions of years. As the limestone and organic-rich sediments of a vanished range are pulled deep underground, they are subjected to immense heat and pressure, locking away vast stores of carbon that would otherwise warm the atmosphere. This slow, relentless recycling has maintained Earth's climate within a habitable range for eons, a stark contrast to the sudden, massive release of carbon from human industry over a mere 2 centuries. The disappearance of mountains into the abyss is not just destruction, it is a fundamental part of the planet's life support system. Our current coastlines are not fixed. The fate of Doggerland, a once inhabited landscape now sleeping beneath the North Sea, is a direct parallel to the future of our own coastal mountains. The highlands that today define shores from California to Norway will, in a geological instant, face the same slow drowning. Understanding the mechanisms of past submergence, from rising seas to sinking land, allows us to move beyond abstract projections of sea level rise. It forces us to visualize the specific loss of landmarks we consider permanent, translating data into a tangible, human-scale reality. The ghost mountains beneath the waves are a preview of a future transformation already in motion. Ultimately, these vanished landscapes offer a dual perspective, both a warning and a strange comfort. They warn that the planetary changes we are unleashing will reshape the world for millennia, erasing familiar horizons and redrawing maps. Yet they also reassure us that Earth is a dynamic, resilient system that has endured far greater upheavals. Our current environmental crisis is monumental in human terms, but it is a brief event within the deep time of mountain life cycles. This does not diminish our responsibility, but it frames it. We are not destroying a static planet. We are radically accelerating processes that usually unfold with a slowness beyond our perception. The ghost mountains remind us that we are living on a world of profound impermanence, and our task is to navigate this change with wisdom, not as masters of the land, but as its temporary guests. A single story is often just a fragment of the truth. When the precise data from a gravity sensor aligns with the cadence of an ancient songline, a ghost mountain begins to materialize in a new and profound way. This is the power of interdisciplinary synthesis, where the hard evidence of geology does not silence legend but instead listens to its testimony. For example, sediment cores from a coastal plain might reveal a mineral signature unique to a specific type of granite, suggesting a nearby highland that has since vanished. That geological clue gains a human dimension when placed alongside an indigenous oral history describing a sacred granite peak that was lost to the rising sea. The science identifies the what and the where, while the story provides the when and, most importantly, the why it mattered. This partnership transforms a geological curiosity into a chapter of human history. Statistical analysis adds another layer to this collaboration. By studying the frequency of certain motifs in mountain legends across different cultures, researchers can identify patterns. A story about a mountain that sank as punishment for human arrogance appears in many traditions and is often purely symbolic. But a detailed account of a specific peak's eruption and collapse, with descriptions of its unique shape and the rivers that flowed from it, is far more likely to be a memory of a real event. These different forms of knowledge are not in competition. They are complementary lines of evidence in the greatest cold case of all, the reconstruction of our planet's forgotten past. This synthesis forces us to expand our definition of what counts as data. A core sample is data. The isotopic age of a rock is data. But so is a 1,000-year-old poem that describes the exact color of the sunset behind a ridge that no longer exists. Both are records of observation, one encoded in mineral chemistry and the other in human language and memory. By weaving these threads together, we create a tapestry that is far richer and more complete than any single discipline could produce alone. We begin to understand not only how a mountain disappeared from the land, but also how its absence echoed through generations, shaping the very identity of the people who remembered it. This approach reveals that the ultimate mystery is not the ghost mountain itself, but the enduring human need to map our world, both in stone and in story. Our journey through these lost peaks uncovers a planet in constant, breathtaking motion. These ghost mountains teach us that an empty space on a map is not a void of information, but a classroom. The absence of a mountain can reveal the processes that dismantle it, the climate that shaped it, and the human cultures that immortalized it, proving that what is missing can be as profound as what remains. This scientific resurrection of entire ranges, pieced together from gravitational whispers and fossilized leaves, is a testament to our relentless curiosity. It is a profound demonstration that humanity can, through ingenuity and persistence, reconstruct worlds that time itself has tried to erase. The most powerful understanding emerges when hard data and ancient story meet, when a sediment core confirms the tale told in a 1,000-year-old song. This dialogue between the hammer of the geologist and the voice of the storyteller creates a richer, more complete history of our home, one written in both stone and memory. So the next time you stand before a mountain, see it not as a permanent monument, but as a temporary sculpture. It is a work in progress, destined to one day join the ranks of the ghosts we have chased. Yet its story, the tale of its rock and its meaning to those who lived in its shadow, will never truly die. It will simply transform, waiting for a future generation to listen closely to the echoes it left behind in both the earth and the human